video on factoring a difference of squares. By the end of this video, you should be able to identify and remove a GCF from a polynomial, identify perfect squares and their square roots, and use the difference of squares pattern to factor special case expressions. Alright, so as the name implies, difference of squares. So we're talking about some square roots and a difference meaning subtraction. I have some review problems for you types like we've done in the past. So let's go ahead and multiply these together. So I have x minus 4 times x plus 4. Okay, so if we have x times x, that would give us x squared. X times positive 4 is a positive 4x. Negative 4 times x is negative 4x. And negative 4 times positive 4 will give us negative 16. When I combine my like terms in the middle, I end up with x squared minus 16. Okay, let's try another one. 2m times 2m will be 4m squared. 2m times 1 is a positive 2m. Negative 1 times 2m is negative 2m, and negative 1 times positive 1 will be negative 1. When I combine my two like terms in the middle, I end up with 4m squared minus 1, because they're going to cancel because they're opposites, just like these guys did. Okay, let's try one last one. So I have 3a times 3a for 9a squared. 3a times 2b will be 6ab. Negative 2b times 3a will be negative 6ab. And negative 2b times positive 2b will be negative 4b squared. Just like the other times, these two in the middle are exactly the same except their signs are opposite. So when I combine them, they'll cancel out. And I'm left with 9a squared minus 4b squared. Okay, so let's take a look at this. Going back to the idea of the title of the notes, factoring a difference of squares. Notice when I had these parentheses, the parentheses were the same in each case except their signs were opposite of each other. All three of these cases, the numbers and the variables were exactly the same, but the signs between the parentheses were opposite of each other. And what that set us up for was the center section, that b value in the middle of your quadratic or polynomial was canceling out because they ended up having opposite signs. And what happened is I ended up having a perfect square. X squared is a perfect square because it's x times x. 16 is also a perfect square. And we got it from multiplying 4 times 4. Okay, and the factor the difference of squares. So I had two perfect squares with subtraction between it. Let's take a look. Is 4m squared a perfect squared? It is. It's 2m times 2m, and 1 would be 1 times 1. Okay, and we have subtraction, a difference of perfect squares. And our last one, is 9a squared a perfect squared? It is 3a times 3a. 4b squared is 2b times 2b, and you're subtracting between them. Okay, so let's see kind of what that means for us. So a binomial is considered a perfect square if both terms in the binomial are perfect squares. So that's what we were looking at. Both of the terms in these are all perfect squares. And we can identify it. Here's what it looks like. You're going to have a perfect square for your first term. A perfect square for your second term. and then you're going to have subtraction in the middle. Okay, that's the difference of perfect squares. So, just like other factoring problems, we want to be sure to check for any GCF before we begin to factor anything. Always check for GCF. If both terms are perfect squares, you need to determine the following. What is the square root of the first term? That's what we did here. The square root of x squared is x, so it's really x times x. What is the square root of the second term? For 16, we said it's 4 times 4. And then you're going to put them in this factored pattern for a squared minus b squared, which is just a plus b times a minus b. Okay, they look the same. The variables and the numbers will all be the same. What will be different is their signs. So let's give a couple of these a try so you can see it in action. So very similar to what we were doing, except instead of starting off with the binomials this way and multiplying together, I'm going to give you the answer and we're going to go backwards to the binomials. So let's take a look. So what times itself will give me x squared is x times x. So that's your 80. 4 is 2 times 2. And we're going to follow this pattern. Okay. And notice we have 2 of each. So we're going to do one with a plus and one parenthesis with the minus. We can check this. X times x is x squared. X times negative 2 is negative 2x. 2 times x is plus 2x. 2 times negative 2 is negative 4, giving us x squared minus 4. So this will be the pattern that shows up on all difference of squares problems. 2 perfect squares with a minus in between. Figure out what makes each term, what times itself makes each of the 2 terms, and then you distribute them evenly between the 2 parentheses, and one's a plus and one's a minus. We could have written the first one as the minus and the second one as the plus. Which one's plus and which one's minus does not matter. Okay, so let's take a look at number 2. 4b squared would be 2b times 2b. 9 is 3 times 3. And then we're just going to follow our pattern to get that middle term to cancel out, so I only have 2 terms left. One of them has to be positive, and the other one has to be negative. And that's that positive negative like that that makes the middle terms go away. Okay. Take a look at number 3. 3 is one people get confused about because they're like 1 is 1. But you can get 1 by taking 1 times 1. It is a perfect square. Okay, 9x squared would be 3x times 3x. And then we're going to use our pattern. 3x plus 1, 3x minus 1. And remember, the pattern works because of these opposite signs. That's what makes the middle term cancel out, so you only have 2 terms remaining. Okay, so let's take a look. Number 4, 16c squared, that would be 4c times 4c. 25 is 5 times 5. The problem here is this, right there. That's a plus sign. That's a sum of squares. Notice these notes are called a difference of squares. This cannot be factored. This is what we call prime, because it does not factor. We could try it. So if we did 4c plus 5 and 4c minus 5, if you missed it, when we check this, we get 16c squared minus 20c plus 20c minus 25. Those guys cancel. See that? Minus 25. This is plus 25. So you cannot factor this. So that is something that you need to pay attention to, that it needs to be a negative in the middle. Okay, so let's look at some problems with GCF. You should always be checking to see if there's something in common before you begin the problem. So when I look here, we got 2 and 8, and I know they both share a 2, which if I take that out, I'm left with x squared minus 4. So x squared you get from x times x. 4 is 2 times 2. Be sure to keep your GCF, and then we have x minus 2, x plus 2. All right, let's try another one of those. Let's look right below it, number 3. Looking for GCF. GCF, greatest common number that they have in common. So they're both even, but that would make that a 27 and this a 12 if I divided it by 2, and they both still share a 3 in common. So I went bigger and I went with 6. So when I take the GCF out, I'm left with 4c squared minus 9. So anytime you see there's still a power greater than 1, you need to check it out to see if this will go again. Well, 4c squared is 4c times 4c. We have a minus, and then we have 3 times 3. So my final answer will be 4c minus 3 times 4c plus 3. Remember what I said before, which one's plus and which one's minus, doesn't matter. But the numbers have to be the same in both parentheses because they're coming from perfect squares. We're taking the square root and putting a number from each one in each parenthesis. All right, so hopefully this was helpful. Let me know if you have any questions. See you in class.